afternoon also on my behalf. I'm Anja Zajc, a researcher and the director of a small company, FRAZA, that managed to find its way to a collaboration in a Europe co-funded project, DEEP PPU. FRAZA is a small family-run company from Slovenia. It's basically only two of us, me and my brother, Zajc, supported by our parents. It's a research company focused on basic research and innovation in power electronics and power magnetics. The inspiration behind all of this research and innovation is an old saying by a Dutch philosopher, Desiderius Erasmus, who said that prevention is better than cure. Transferring his cognition into the field of power electronics and power magnetics opens whole new horizons, since the result will always be better if you're able to avoid the problem to occur in comparison to fixing the consequences afterwards. Wide field of expertise allows FRAZA to use unique approaches to profoundly understand and avoid the state-of-art problems. The company has over 40 years of experience in the aforementioned fields. It all began when Franz Zajc, one of the company owners, and my father, invented an electrical motor which achieved over 10 kilowatt per kilogram of specific power and was, at least according to General Motors, said to be 25 years ahead of its time. The motor was able to simultaneously achieve high torque and high rotating speed on account of low winding inductivity, which meant that the state-of-art switching frequencies had to be increased in order to drive this motor. Accordingly, he invented a driving principle and managed to drastically increase the switching frequencies. In the year 2000, we were already switching 100 volt and 20 amp signal with 1 megahertz with silicium devices. But when filtering the high-frequency output signal, there was no inductor on the world to withstand the high ripple conditions, which led to new inventions in the field of power electronics and power magnetics. The research resulted in 25 patents all over the globe, which cover our three main research areas, from multi-phase, multipole electrical motor, near-zero interlock driving principle, high quality factor magnetic components, of which the NZ driving principle has so far been the only one to have been disclosed to public in a publication. The cutting-edge technology has led the company to be involved in some interesting projects throughout the years. We made the world's fastest rotating high-torque motor for a dental application in correlation with the German company Phytron, made stator magnetics for the world's fastest rotating electrical motor for a Swiss company Celeraton, made planar magnetics with extremely high coupling ratio, were included in care system for BMW, Williams, Formula One, and the last but not least, the Google Little Box Challenge, where we managed to make a filter inductor with the highest quality factor on the world. Nevertheless, although patenting the knowledge, all this research remained mostly secured within the safety of our home. It all changed with the publication of the article on the IEEE PCIM conference in Nuremberg, Germany, where we got in touch with Power Electronics Department of Fraunhofer ECM Institute. This connection led to us competing in the Google Little Box Challenge in a team along with ETH Zurich and Fraunhofer ECM Institute, which further on led to the involvement in the DEEP PPU project, as we were suggested to Airbus CRISA by ETH Zurich. One day we just got a phone call asking us whether we'd be willing to cooperate in the Europe co-funded project DEEP PPU, to which, of course, We answered that we would be delighted and very honored to be a part of such an incredible team. Our main role in the DEEP PPU project is designing and producing custom-made magnetic components. We work in a very close collaboration with Polytechnic University of Madrid, trying to find a solution for the thruster electronics to have the minimum possible weight, volume, and losses, which is of crucial importance for space applications. To overcome the physical distance between the Polytechnic University of Madrid and FRAZA, we have established bi-weekly meetings coordinated and supervised by Airbus CRISA and are in a constant communication via email. About 5 months ago, we even had an opportunity to meet in person on a preliminary design review meeting in Montmirail, France. The Polytechnic University of Madrid has done a wonderful work on researching for the best electronics option. They came out with a variety of possibilities for the electronics, and for each of the potential options, they gave us the input data for the magnetic components, and we would then calculate an optimal magnetic design regarding volume, mass, and losses, and then give them the feedback for the final system loss and volume evaluation. Once the optimal design combination was chosen, we developed custom production tools for each magnetic design, produced and tested the prototypes. The collaboration in the Europe co-funded project DEEP PPU is an absolutely amazing opportunity for a small company such as FRAZA. It broadens existing horizons and opens new ones. It has an extremely wide impact. One of the crucial benefits, I'd say, is increased market recognition and publicity, which is of huge importance considering the narrow field of specialization of a small company such as FRAZA. Involvement in such a project is opening new market possibilities, especially since it helps the small company to improve their existing technologies and even implement new technologies to the company.